In the last lecture, we had discussed few problems on the vertical circular motion. The concepts we have discussed already, and I think I had taken few problems on that. But what I had felt that guys, I should take few more problems, and if I'll take those few problems, I think it will crystallize your concepts on this particular topic. And it is very you can say very conceptual topic, because it combines the concepts of circular motion as well as what the work for energy chapter. Okay, so that's why it becomes more important aspect in terms of learning. Okay, so guys, I thought that I'll take few more problems. Okay, so guys, let me continue this problem thing today also. Okay, so let's start guys. Okay, so see, this is problem number 4. So I have already taken the 3 problems on the vertical circular motion. Today guys, I'm going to take few more problems, maybe probably more 3 more. Okay, so let's start guys. So this question is, guys, this question has come in JEE Advance. Basically when the JEE was not JEE Advance, it was only IIT JEE. At that point of time guys, this question has been come, and the question is saying like this guys, that there is a simple pendulum, you can say, having a length of string, let's say actually it is given guys what, 1 meter. Between sorry guys, it is saying that below the point of suspension there is a nail that has been placed. Okay, there is a nail guys that has been placed, whose distance is from the point of suspension is what guys, it is x by 10. Okay, it is what guys, x by 10. And the particle is actually guys, it has been placed from the vertical at a 60-degree angle. Okay, so the question is, what should be the value of x, what should be the value of x, so that the particle, when like you can say, when the string hits the nail, okay, the particle should be able to what, do the full circle. Okay, particle should be able to do what, this full circle means, as this string will come like this guys, what will happen, it will hit the nail, and then as it hit the nail guys, it will move in the circle like this way with this remaining length. And guys, it should be able to do what, a full circle in that case. Okay, it should be able to what guys, the full circle in that case. So in that case guys, if suppose this is your C and this is guys O, so O will become your new center of what, the vertical circular motion. I hope you understood the whole scenario of the problem guys. So guys, it's a very simple problem actually. If you see, the thing is, when the rod, sorry, when the string will come and guys reach here, let's say this remaining length is what guys, y, and when it will guys reach here, the velocity should be how much, it should be actually root 5 gy. If that much is the velocity you are going to have, then in that case it should be able to what, do the full circle. I hope you're getting my point. Okay, so guys, what is our requirement, that when it will reach here, when it will reach here, the velocity should be equal to what guys, root 5 gy. Okay, so if we fulfill this condition, I think our job is done. Okay, so what we can write guys here, we can simply write that guys, if you see in this case how much height the particle has traveled. So if you see guys, this is 1, so guys, this distance will be how much, this will be 1 cos 60. Okay, which is how much guys, 0.5. so it means how much down the particle has gone in terms of height guys, that is what, 0.5 meter only. So guys, what we can say, we can say that 0.5 into g is how much, 10 into 1 minute guys. Okay, so let's see, it will be m into g is what guys, 10 into what, h is what, 0.5, is equal to change in kinetic energy guys, and that will be what, half m v square guys, okay, minus what, 0. So guys, if you see cancel, because 0 why guys, because we have leave it from the rest, okay, the particle has left the place from the rest guys, okay. So cancel, so it will become what guys, it will become v is equal to under root 10. So guys, if v is under root 10, then this root 10 guys means 10 should be equal to what, your 5gy. I hope you're getting my point guys, okay. So from here we can get y is equal to what guys, that is 1 by 5 meter. I hope this is settled guys. G we are taking 10 only. So guys, now y will be how much, y will be nothing but guys what, 1 minus x by 10. So that is equal to what guys, 1 by 5. So what we can say, 1 minus 1 by 5 is equal to what, x by 10. So from here guys, if you see, this is 4 by 5 is equal to x by 10. So this is this guys. So x will be how much, 8 by 10, or 0.8 is what guys, sorry, 1 minute guys, the value that they have asked for is how much guys, is x, and that will be what guys, that will be simply 8, okay. So the distance, if somebody asks guys that what would be the distance from the suspension point, where should we place the nail below of that, is how much guys, that is 0.8 meter, okay. It should be what guys, 0.8 meter, but that was not the question that they had asked. They had asked the value of x. So guys, x value will be what, 8, nothing else, okay. So I hope this is settled guys, okay. This is settled. So it's a simple problem actually, if you see, not difficult as such, just basic concepts you have to align, and you can get the answer, okay. Now guys, I'll move to the next problem. This problem that I'm going to take is also actually came in the JEE, and this problem will be what guys, it will become our problem number 5, okay, problem number 5. So guys, just let me go through the questions once, okay, for you, so that after that we can start discussing guys. So it is saying like this, that there is a particle guys, okay, which has been you can say going to be, just a minute guys, let me make this, okay. So guys, this is the point A and this is the point B. So they are saying guys like this, that V is sufficient so that the particle can reach to point B. Find the angular position of the particle when its speed will be v by 2. And guys, the options were given like this way, that theta, A option guys is given, theta is equal to pi by 4. B is given guys what, it is that theta will be less than pi by 2 and greater than pi by 4. And C is guys what, it is pi by 2 greater than and less than what, 3 pi by 4. And D is what guys, 3 pi by 4 to pi, okay. So this, it's a very interesting problem that I feel, because a lot of students, okay, who like maybe haven't listened the class properly, or you can say they have some sort of just a blurry memory about this vertical circular motion concepts, they generally guys do a lot of mistakes here, okay. And even if the student is good also, in the hurry guys, he might do the mistake that I'm going to show you, that generally happen in this problem, okay. So let me start guys this question. So guys, it's actually simple problem, but a lot of learning can happen in this problem actually guys. So the first thing is, if you see, what is the first mistake that happens guys here? The first mistake is that student thinks what, that we have to just send this particle to what, the topmost height. Okay, so to send it guys, of course we need only what, the velocity, how much, yes, root 4 gl. Okay, so that is the thing that they are having actually from the topic that we have learned about what, when the rod and plus bob combination was there. So they think that we have to just reach it what, just we have to send it what, up to here. So the velocity should be needed how much, root 4 gl only. Okay, but actually that is not the case. Okay, why? Because here it is what, string plus bob combination guys, and if you want to send it guys what, up to this maximum height, means at a point B, there is no way other than what, that your velocity should be what, more than root 5 gl or equal to root 5 gl. Okay, otherwise it can't go. If your velocity is less than root 5 gl guys, what is going to happen? It will reach somewhere and after that it will do some sort of projectile motion, you know that. Okay, so it means the first thing that we have to keep in mind guys in this case, that velocity can't be equal to what, root 4 gl. Okay, in this case to reach the point B, it should be what, root 5 gl only. Okay, there is no other way around. So the first thing guys, what we will calculate from here, that V will be how much guys, that is root 5 gl. Okay, so guys what we are looking at, we want that speed should become what, half of that. What should be the angular position? So guys V by 2 will be what, simply we can say it is half of 5 gl, which is equal to what guys, which is equal to 5 by 4 gl. Okay, so guys if I use my formula, simple relationship guys, that is what, V square is equal to V naught square minus 2 gl 1 minus cos theta. We can directly get what guys, the theta angular position, and if we get guys angular position, I think from there we can judge that in which range the theta would be lying. Okay, so guys if you see here what happens, that V square will be how much guys, that will be 5 by 4 gl, and guys this will be what, this will be 5 gl only, and this is what guys, minus 2 gl 1 minus cos theta. So guys gl cancel. Okay, and what we are remained with guys, it will be 2 1 minus cos theta is equal to 5 minus 5 by 4. So guys it will become how much, it will become 2 minus 1 minute guys, let me 2 1 minus cos theta is equal to 20 minus 5, that is what guys, 20 minus 5, that is what, 15 by 4. So it will become what guys, 1 minus cos theta is equal to 15 by 8. So guys it will be 1 minus 15 by 8 is equal to cos theta. So it will become what guys, 7 by 8 minus case. Okay, so it means of course it is going to be what, obtuse angle, and the value should be what guys, near to 1 I guess so. Okay, so guys if you see the options, the first thing is that these two will be what, eliminated. Now guys by seeing these two options, generally what I have seen, it is my observation in my lectures, that lot of students guys take this answer. Okay, directly they take this answer guys, because it appears that this is a obtuse angle, so I think that would be negative, that should be the answer guys. But actually if you see guys, the cos value is going to be what guys, it is almost near to what, minus 1. Okay, so it means guys actually it will not lie in this range. Okay, if you see the values properly, it will lie guys what, in this range. So when you got to this answer guys, what I would suggest that you please check that what is the cos 3 pi by 4 value and where your value is lying guys. You can judge from there directly and you can get that yes, it is what, it is the theta should be more than what, the 3 pi by 4. So guys of course the answer would be what, this. Okay, so answer would be what guys, this. Okay, so guys I'm a left-hander, that's why I take like this way. Okay, so I hope you understood this problem also guys. Okay, so it's a good problem. The right answer is what guys, this, not this. Okay, this is not the right answer, this is the right answer. Okay, so please don't be in hurry when you are attempting these kind of problems guys. Sometimes these questions are easy, but due to just this in hurry, to report the answer, we did this kind of a silly mistakes. So please don't do that, these kind of a mistakes. Okay, now guys, coming to the one last problem guys that I want to take, and this will be what guys, a bit good problem. Okay, actually, so it is also, I think, the old JEE problem, maybe in 1970 or 1980, something like this. Okay, I don't remember exactly, but guys, it's also a very good problem. So problem 6 guys. Okay, so what is this problem guys? What is this problem? So if you see, actually the question says like this guys, let me make it for you. So guys, it is saying like this, that there is a rod like this. Okay, and we have having a bob here at the bottom. Guys, this is asking that what should be the velocity v that we should give to the particle, so that let me make the circle for you. Okay, so if we make the circle like this, I think yes, that might work. Just guys, let me fix it first. Okay, yes, I think this will work guys. Okay, so if you see guys, actually the idea that problem is expecting is that is when you project the particle from here, the particle should go like this, and guys, 1 minute guys, the particle should go like this, and guys, it should hit the peg. Okay, means where the point of suspension is there guys, it should do the projectile and it should what, hit the peg. That is the question. So what should be the velocity v we should give, so that guys, this can happen. Okay, this is the problem. So it's actually a good problem guys. If you want to try, you can pause the video and you can try. Okay, now I'm going to start this problem guys. So it's a good problem. Let's see guys, how do we approach this problem. Okay, so actually guys, what is going to happen, just let me make the figure first. Okay, so guys, if you see, the particle will go like this. Okay, particle will go like this, and suppose guys, at this point guys, it the tension slacks. Okay, t equal to 0, and guys, it goes like this, and let's say hit the peg like this way guys. Okay, so in this case, the velocity will be what guys, here let's say u. Okay, this velocity is what guys, u. So what I'm going to do is guys, see, let's say guys, this angle from the vertical I am taking theta. Okay, I'm taking this angle is guys what, theta. Why I'm taking theta here, I'll let you know guys. So if you see here guys, what will happen, if this is theta, this will be 90, this will be 90 minus theta, so this will be what guys, theta. So because projectile motion guys, generally we know the angle of projection as a theta, and then we remember the formulas and all. So guys, that's why I have taken this as a theta. Why? Because then it makes us easier to what, like contemplate the ideas that we have learned earlier. Okay, so guys, here what I have done it, I have taken this value as what guys, theta, and guys this I am taking as our y-axis, and this guys I am taking our x-axis. Okay, this I am taking as our x-axis, and now guys, we want to find out that the particle goes at this point where the peg is there guys. This is our positive plus axis, and this is our what, plus y-axis. So guys, if I want to write down the coordinate of this point where the particle is going to get hit the suspension, so that coordinate will be what guys, if you see, this length is guys what, L only. So if this length is L and guys, this is theta, so this will be what, L sine theta, and this will be what guys, minus L cos theta. So guys, what we can say, that this position O will be how much, it will be guys what, it will be L sine theta comma minus L cos theta. Now guys, what I'm going to do, I'm going to use the equation of trajectory, and I'm going to fit these two coordinates, okay, that we have gotten in that equation of trajectory, and then guys, we will see that what we can do. So guys, if you see, actually the equation of trajectory that we have learned is guys what, y is equal to x tan theta minus gx square divided by 2u square cos square theta. Is this okay? So guys, here let me put the values. So y will be what guys, y will be minus l cos theta, x will be what guys, l sin theta tan theta minus g guys, l square sin square theta divided by 2. Guys, u we can calculate in terms of I think theta and l. Okay, how guys, if you see at this point guys, at this point the tension becomes what guys, 0. So centripetal force will be what guys, just the component of mg, and that should be equal to what guys, mv square by r. So we can apply the centripetal condition. So guys, let me choose some color so that I can show that. So guys, if you see here, the mg is acting in this direction. So if this is theta guys, this will be also what, theta. So guys, what we can say, this will be our centripetal force right now because tension has been 0. So guys, mg cos theta will be equal to what, mu square by what, l. I hope you getting my point. So guys, u will be how much, that will be gl cos theta. So guys, that will be what, our u. So we can replace guys what, u square with the gl cos theta. So let me put those values guys here also. So it will be gl cos theta into what guys, cos square theta. Okay, so like guys, if you see, g cancel, 1l cancel guys, 1l from here, 1l from here, 1l from here guys, get cancelled. So what is remaining guys, minus cos theta is equal to guys, let's convert everything in the sin theta and cos theta guys. So this will be what, sin theta upon cos theta minus sin square theta divided by guys what, 2 cos cube theta. Let's more simplify guys this. So let's take the LCM guys here, what, equal to 2 cos cube theta. So guys, it will become what, it will become 2 cos square theta into sin square theta minus sin square theta. So guys, it will go this side, so it will become 2 cos 4 theta, and guys, this will become 2 cos square theta sin square theta minus sin square theta. Now guys, what I will do here, some mathematical manipulation. So I have taken sin square theta guys, left side, and I have brought the cos 4 theta guys, right side. Why I have brought it, you can see now what the magic is going to happen guys. Here sin square theta, if I take 2 cos square theta guys common, what I'll get remained, sin square theta plus cos square theta guys, that is equal to what, 1. Okay, so guys, what we left with, tan square theta is equal to what guys, 2. It means guys, tan theta is equal to what, root 2. So guys, we got the tan theta. So guys, if we got tan theta, now we can calculate guys what, u. So if you see guys, if we can get u, we can get the v also guys. So u is equal to what guys, under root of gl cos theta. So guys, for getting the cos theta, what we can use this simple right angle triangle thing. So guys, it will be root 2, this will be 1 guys, so this will be what, this will be 2 plus 1, that is guys what, root 3. Okay, so guys, cos theta will be what, it will be under root of gl 1 by root 3. So guys, our u will be what, gl by root 3 square root of that. Okay, so guys, u we got. Now we can find out guys v. So how do we get guys v? So guys, in that case, if you see, let's say this angle right now guys, I am calling this angle guys, I am calling now alpha. Okay, this is our angular position from the start guys. Okay, so this angle I am taking as guys what, alpha for right now. So if you take that value guys, what we can write, we can write that v square is equal to what, v naught square minus 2gl 1 minus cos alpha. I hope you remember guys. Okay, so guys, we have to calculate, v naught we have to calculate guys. So it will become what, gl by root 3. Okay, and guys, this will be what, v naught square minus 2gl 1 minus cos alpha guys. Okay, so cos alpha will be how much guys, if you see, actually alpha is guys nothing but what, 180 minus theta. Okay, if you see guys, this is what, this is how much guys, 180 minus what? Theta. So guys, I can replace the alpha by what? 180 minus theta. So guys, it will become what? It will become cos pi minus theta. So guys, it will become what? GL by root 3 V naught square minus 2 GL. 1 minus cos minus pi minus theta is what, guys? Minus cos theta. So it will become 1 plus cos theta. I hope this is settled, guys. Okay, so V naught square will be equal to what, guys? GL by root 3 plus 2 GL 1 plus cos theta, guys. Cos theta is what? 1 by root 3. We have discussed already above. So guys, GL I can take common. Okay, so if I take, guys, GL common, we will get 1 by root 3 plus 2 by root 3. I hope this is settled, guys. So it will become GL, guys, 2 plus 3 by root 3. I hope this is settled also, guys. So it will become what? GL 2 plus root 3, guys. Okay, so V naught square is this, guys. So V naught should be equal to how much, guys? Under root of GL 2 plus root 3, and that is the, guys, what? Answer. So you can see, guys, how beautiful this problem is actually. Okay, how much analysis has gone in this total thing. Okay, and even the math is also quite nice, I would suggest. Okay, so okay, guys, so I think now you have gone the clarity in the vertical circular motion have come what? A little better, I guess so. Okay, now guys, one last problem I'm going to give you, and I would expect that if you should solve this problem, and if you can solve, guys, just let me know the answer in the comments if you get that. Okay, so guys, the question is guys, suppose this is a rod, guys, or sorry, the string only. Let's say, guys, L is the length of the string. Guys, I have given this is velocity what? Root 4 GL. So my question to you is, guys, what? That we know that it will go like what, guys? It will do like this, and then, guys, what? It will do some projectile motion like this way. Okay, so let me make the diagram for you so that you can try actually this problem, guys. So my question is, guys, let's say here at this point, guys, let's say the string slacks, guys. Okay, and let's say the particle goes like this and do the projectile motion something like this. Okay, so guys, my question is, when again, guys, the string will become tight, means here t equal to what, guys? 0, and here the t will become what? Not equal to 0. So my question to you is, guys, what would be the time interval? What would be the time interval after which string will become tight again? So guys, it's a good problem. You can try this problem by yourself, and if you get some answer, please let me know in the comments. Okay, so guys, I think now I feel satisfied in terms of vertical circular motion. Now one thing that we have to cover is what, guys? Is the rotating frame and the fictitious forces, like the centrifugal force, Euler force, and the Coriolis force. In general, guys, people doesn't teach the Coriolis force and the Euler force. Okay, but we are going to cover those also, guys. Okay, I have seen only few teachers they try to entertain that part of the concepts. Okay, but we will try to, guys, explore that part of the chapter also. Okay, so that's it, guys. Okay, for today, I'll see you in the next lecture.